Hello, Algebra 2AB. This is the last section that we have in our trig chapter. This is chapter 12, day 8, which is law of cosines. All right, so today we're going to talk about law of cosines and how we can use that in some non-right triangles to find sides and angles, sides and angle measures in a triangle. So last lesson we talked about law of sines. Today we're talking about a different law of cosines. All right, so if triangle ABC has side lengths of A, B, and C, then this is the three different equations that we could set up. And I know there's a lot here. We got a squared equals b squared plus c squared minus 2 times b times c times cosine of a. And notice how a lot, like most of this looks like Pythagorean theorem. We just got a little bit extra here. B squared equals a squared plus c squared minus 2a times c times cosine of b. And then finally c squared equals a squared plus b squared minus 2 times a times b times cosine of c. All right, this works on non-right triangles as well. And this really is just, kind of reworking Pythagorean theorem and using some trig to help us find these side lengths and angle measures. All right, so one hint that I'm going to give is based on the side or angle that we're looking for. So if we're looking for side or angle A, we're going to use the equation that starts with A. If we're looking for side or angle B, we're going to use the one that starts with B. And then finally, if we're trying to find C, we're going to use that one that starts with C. So if we take a look at example 1 here, all right, we're looking for we're looking for side B. All right, we already have sides A and C. We're just looking for side B now. All right, so if we're looking for side B, we're going to use that equation that starts with B. So that's b squared equals a squared plus c squared minus 2ac times cosine of angle B. Now we're going to plug in what we know. All right, so we know a is 7 squared. We know a is 7, and then c is 12. So we have plus 12 squared minus 2 times a times c, 2 times 7 times 12 times cosine of angle B, which is 41 degrees. All right, and now I just want to run through okay, well, how do we solve for B here? One thing that I like to do is I like to bundle in this whole quantity together. So I like to put parentheses around this because um, like in this scenario, all these things are multiplying. So that's one quantity. Obviously, we don't know what that is, but that's just one quantity. So one thing that we could do is we could type this whole thing in as long as we have those parentheses there. And just as a forewarning, remember when we type in cosine in our calculator, it creates a set of parentheses for us. So remember, we need to have two terminating sets of parentheses at the end here. All right, so we have 7 squared plus 12 squared minus this whole quantity, which I'm not going to say it again. And if we type that into the calculator, we get about 66.2. Okay, and then when we take the square root, and I really mean 66.2, and I'm just going to write a dot, 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 because I'm using that exact answer that the calculator gives to find B. So we're going to take the square root and then only round the answer to the nearest tenth. I'm not rounding those intermediate answers to the nearest tenth, just the final answer here. So we get 8.1. All right, let's take a look at the next example. Let me clear the board. All right, in this one, we want to find the unknown side length, which is t. We have the other two sides. So in this one, all right, we could say that we're trying to find t, so we would want something that starts with t. So that would be t squared equals s squared plus r squared minus 2, and I'm just going to write a little parentheses there, 2 times s times r times cosine of angle t. All right, notice in each one of these versions of law of cosines, it starts and ends with A, starts and ends with B, starts and ends with C. Then everything else is the other two variables. All right, so that's how we know how we could set this equation up. We have t squared, starts and ends with t. Everything else is s and r. All right, now let's plug in what we know. So s is 4, r is 6, and then angle T is 35 degrees. All right, so we have 4 squared plus 6 squared minus the quantity, this whole quantity, 2 times 4 times 6 times cosine of 35 degrees. All right, if we do that in our calculator, we get 12.7. Take the square root, and that's approximately 12.7. Take the square root and round to the nearest tenth, and we get 3.6. All right, so the hardest part of these problems is going to be to find the angle measure. All right, so in the next 2 examples, we're going to talk about finding the angle measure. All right, algebraically speaking, it gets a little bit more difficult, but as long as we're confident in what we're doing in terms of what we're doing with our calculator and what the calculator is telling us and what we're telling the calculator to do, it's not going to be too difficult. All right, so let's take a look at this example. All right, we're looking for angle B. That means we're going to use that law of cosines that starts with b. So b squared equals a squared plus c squared minus the 2 times a times c times cosine of b. All right, and we have side b, so that's going to be 11 squared equals 5 squared plus 8 squared minus 2. And now, now, once again, I'm going to write parentheses around this. 2 times 5 times 8 times cosine of angle B. I'm just going to keep those parentheses there for the time being. So we have 11 squared, which is 121. 5 squared, which is 25. 8 squared, which is 64. And then I'm just going to do 2 times 5 times 8, which is 80, cosine of B. All right, this is not something that we could just type this, this whole right side or whatever into the calculator. We have to undo this, this equation to isolate B. All right, so we want to get cosine of B by itself. The first thing that we could do is just subtract 25 and subtract 64. Okay. I'm just going to rewrite really quickly. If we combine these two, that's 89 minus 80 times cosine of B here. One thing you might be wondering is, why am I writing parentheses around this whole quantity? And one thing that I'm trying to avoid is a common misconception that we could subtract these two numbers. All right, 80 is being multiplied by cosine of B, so that you could think of as being bundled with the cosine of B here. All right, so we can't actually do that operation, which is, I think, one of the most common mistakes that gets made when doing this problem. So the next thing that we've got to do is we've got to subtract 89, like I was saying before, on both sides, and we'd get 32 equals, now I'm just going to write it without those parentheses, negative 80 times cosine of B. Now to get rid of negative 80, we just divide by negative 80 on both sides. 32 over negative 80 is about negative 0.4. Now we've isolated the cosine of B. And this isn't so hard because we know how to get rid of that cosine. Just take inverse cosine. So B equals inverse cosine of negative 0.4, and that would give us 113.6 degrees. All right, last one, final one, here we go. Whoops. Man, oh man. There we go. Now we're talking. Here we go. Final one. We got to sketch a diagram, and we've got these side lengths. We don't really have to sketch a diagram. It just suggests, hey, let's sketch a diagram because that might make it easier, as it often does. Label that triangle A, B, and C, and then just fill in some of the stuff that we know. So side A is 3, side B is 7, side C is 9. And we're looking for angle C. So if we're looking for angle C, we're going to use the one that starts with C. So side C squared equals A squared plus B squared minus 2 times A times B times cosine of angle C. Now let's plug in what we know. Side C is 9, side A is 3, side B is 7. Do the same thing over here. We're looking for angle C. So once again, we got to isolate cosine of C. So just going through this, we've got 81. 9 squared is 81. 3 squared is 9. 7 squared is 49. 2 times 3 times 7 is 42. So minus 42 times cosine of C. 9 times 49 is 58. Subtract 58, and we get 23. So we have 23 equals negative 42 times cosine of C. Divide by negative 42, and we get, I'm just going to write the fraction here, negative 23 on 42. And then to solve for C, like we were saying before, just take inverse cosine. That's how we can get rid of cosine. So C equals inverse cosine of the ratio negative 23 on 42. And that gives us 123.2 degrees for angle C. All right, folks, that's law of cosines. If you have any questions, make sure to message me, email me, and let me know. All right, thank you and have a good day.